Hello, welcome to day 6 of our Python Summer Party Challenge. Today we'll be working with Ben and Jerry's. This is it. So we'll be taking the role of a product analyst to analyze how temperature and seasonality impact ice cream sales using Python, right? So let's dive right in. So if you are new here, kindly check out my previous videos, subscribe to my channel, like, and drop comments. Okay, so these are data sets, and first of all I'm going to run the code. We have our data ice cream data set. Let's check it out. Good, the code is run. So the first question here is to identify and remove any duplicate sales transaction from the data set to ensure accurate analysis of seasonal patterns. Right? So I want to check for duplicates. That's the first thing I want to do. Check for duplicates. I mean those that have the exact match across all columns. Right? Exact match across all columns. So how do I do that? So let's check total duplicates. I'll give a variable total duplicates. Now access my data frame, ice cream data. Duplicated is a function called duplicated, and I want to sum all the duplicates. So let's print total right. So do this. Okay, let's run this and see. We have just one duplicate, one exact duplicate. So what I could do, just put the formatted text. So the next thing I want to check for duplicate ID. Duplicate ID, transaction ID, just the same way we did this. So I'm just going to copy this. This check duplicates ID. Call it ID duplicates. So I want to access just the transaction ID column. Right? Check for duplicates and sum up. So I'm going to do the same thing here. Let's check out what we have here. Total duplicates transaction ID. Yes. Okay, let's check. Total exact duplicate rule is 1. Total duplicate transaction ID is 1. So you're seeing how we're checking, but then step by step. So now I want to remove the duplicates. right? So I'll access my ice cream. I have a new table for ice cream data, sales data clean, right? So ice cream data dot drop duplicates. Then I'm going to working with subsets of transaction ID. So I'm using transaction ID as column to check to drop the duplicates, since we have the same duplicate across board, right? Okay, it's an error. Let's see where it's coming from. ID duplicates. Okay, drop duplicated. Okay, I think it should be drop duplicates. Yeah, let's see. Okay, now we could see we have 59 here and we have 60, right? So I'm just going to add a formatted text. Rows before cleaning. So I want to return the length of this. Rows after cleaning. Okay, we have to be quotes. Yeah. So rows before cleaning 61, rows after cleaning just 60. So the question 2 is to create a pivot table to summarize the total sales volume of ice cream products by month and temperature range. Use the following temperature bins, where each bin excludes the upper bound but include the lower bound. Okay, so this is a little tricky, but let's get right in. The first thing I want to do is to I'm going to be working with date time, my date column. So I need to convert my date column to a date time, natural date time. So I'll convert my date to date time. So how do I do that? I will access my ice cream data frame. I'm working with the claim. Since I've removed duplicates, I'm getting the sales date. I'm going to replace it with go to date time. Now I think it's sale date, not sales date. Just correct that. Save it. So if that's done, then I want to extract my months. Just do the date for the day 5. Extract months. So I want to create a new month column. Let's call sales months, right? So it should be sales dates. Gonna get the M signifies the month, like I said, the D for the day, the Y for the year. Very important to remember that. There's an error here. Sales data claim, very important. Good. So I need this as a string. That's why the type has to be a string. So I'll assign a type to it for ease of working with it. So I'm going to define the temperature. Beans and label. Now let's go to the question. Create a plot table to summarize total sales volume of ice cream products by month, temperature, and temperature range. Okay. Now this is temperature range and bean that has been given to us. So working with this, first of all, we have an array, a bean array, where we store in all our values like 60, 70, 80, that we can pick out from 90, 100. I'm picking 60, 70, 80, 90, 100. Now we are going to add a positive infinite value and a negative infinite value. I'll explain why I added that. Best practice. In case of errors, I'm just going to copy this, paste it as the minus. Right? That's the bean. So the labels, also an array. So it's a text array. So I have less than 60, degree Fahrenheit. So except you can get your degree icon text, I'm just going to use that Fahrenheit. Then ignore this, sorry. So I have 60 to 69 degree Fahrenheit. So yeah, I will have 70 to 79 degree Fahrenheit, right? Yeah, we have 80 to 89 degree Fahrenheit. 90 to 99 degree Fahrenheit. And we have 100 100 plus like this, 100 plus degree. All right. Okay, considering this, we have a bin, which is the value itself and the label. So I'm going to assign the temperature range as a new column. So access clean data. So I want to call it temperature range. Already we have temperature column. So basically, I will iterate it through my bins and return my labels, right? So let's see how we can work that out. The function called cuts. So I want to access my ice cream, the temperature column, the bins, equals to bins, then the labels. Python gives us that is, and remember, right, false. So basically, what this does is that it converts the numeric temperature that we have here. This numeric temperature, it converts it into a categorical value, categorical range for working with, and it's very useful for groups analysis, right? So in simple terms, this takes the raw temperature number and groups them into a meaningful bucket. Get it? Two meaningful buckets like we have here now. This 67 is going to fall under, or what is temperature? 85 is going to fall under 80 to 89 degrees Fahrenheit, right? So we're going to have a range, give it a range, and it makes it easier for analysis. Categorizing it is for graphs, visualization, and the rest. So let's go on. Now, if I'm to print the ice cream with my data table, so we have our results. Now we'll see that we have the sales date, temperature, product name. The next thing I want to do is to create a pivot table. Like a person said, create a pivot table to summarize total sales of volume, ice cream, products by month, and temperature range. So I'm going to create a pivot table. Create a pivot table that shows total sales volume by months and temperature range. So I'll create a variable called, a table called pivot table. So I'll access my ice cream sales clean data. Data clean, right? So I'll convert it to a pivot table. So remember we have our index. Index is going to be our sales months. Then we have a column, temperature range, right? We have our values, sales Then we have the aggregate function. Want the sum. It's an aggregate function. We could have selected probably average as mean, or working with the sum. So I want to feed every empty values. It's the fill value function as 0. Now let's print out the pivot table. So I'm going to comment out this. Let's see what we have. Good. So for this month, we'll see the sales value, sales volume for each temperature range. So the index is our row, the column is our temperature range, the value is this, then I replace values with 0. If we're to use, we could use probably let's say mean. So this will give us the average, right? Let's check it out. We are working with sum as the total we have here. Total sales, not average sales. Total sales volume. Okay, so question 3. It says, can you detect any outlier in the monthly sales volume using the inner quarter range method? A month is considered an outlier if falls below quarter 1 minus 1.5 times IQR of above quarter 3 plus 1.5 times the IQR. Okay, this is a little tricky, but let's take it step by step. First things first, I'm going to get the aggregate total monthly sales volume, right? That's the first thing I want to do. I want to get my aggregate the total monthly sales volume. So I'm just going to call this monthly sales. The reason I'm using all of these titles for better understanding, probably using MS, using monthly sales, but you can understand what we are working with. So I'm working with clean data. So I want to group it by number one, group by sales months. Since I'm working with the monthly sales months. So and the sales volume, we have a sales volume column. I want to sum it up and reset index. Yeah. So after doing this, I want to calculate the quarter 1, the quarter 2, and the IQR, right? So quarter 1. So let's put that in. Calculate quarter 1, quarter 2, IQR. My quarter 1 is actually my monthly sales. So I'm getting on the sales volume, right? There's a function called quanta. So my quarter 1 is 0.25, the quarter 2 is 0.50, the quarter 3 is 0.75. We have 4 quarters in by 100. So the first quarter is 25%, second quarter is 50%, then the third quarter is 75%, and we also have the 100%, which is the fourth quarter. So I'm going to do the same thing for quarter 3. Monthly sales, working with sales volume. So quarter 3 is 0.75, right? So my IQR is actually quarter 3 minus quarter 1. Quarter 3 minus quarter 1. That's the IQR. Now I have to determine the bonds. There's the lower bond and the upper bond. But for the lower bond, like it told us here, the quarter 1 minus 1.5 times the IQR, right? So quarter 1 minus, put in the brackets, 1.5 times IQR, right? Then the upper bond is, it told us here, is quarter 3 plus 1.5 times the IQR. So 1.5 times IQR, right? Good. So we need to identify the outliers now. Let's identify the outliers. So I'll call it a variable outliers. So what are the outliers? From the monthly sales, I'll look at comparison of where the sales volume is lower than the lower bond, or where it's higher than the upper bond, right? So I'm going to work with where the monthly sales, that's the sales volume is lower than the lower bond, or where the monthly put this in the brackets. Sales in the brackets, close the brackets. Sales volume is higher than the upper bond. So I'm taking either the monthly sales is lesser than the lower bond or greater than the lower bond. Right, so it's here. Now let's print out our variables. Lower bond is bond let's check what we have there. Okay, it's an error here. Sale months, not sales months. Let's correct that. Good. So lower bound is this, upper bound is this. So what's the outlier? Outliers month is sales month and the sales volume. So I want this to enter a new line. So I'm just gonna do n enter a new line. Good. Okay. So we're able to detect our outliers in the monthly sales using the IQ arrow method. So now we're going to find out the months that have outliers. So to see the 7th to July of 2024 and the June of 2025. So we've come to the end of today's class. If you have any question, kindly drop on the comment section. If you are new here, kindly subscribe to my channel, like this video. Thank you. Thank you for watching. If you haven't subscribed, kindly subscribe so that you can stay updated on the remaining days of the Python Summer Party Challenge. See you in the next video.